Last examples. Let's start with example number 9. This one says we need to start by completing the square. Now, some of you may not remember completing the square, so let's remind you of it. If I want to complete the square, what I'm essentially doing is I want to put x plus, actually let me write this down here. I want to do x plus something squared plus something. That's what I want to end up with. So I kind of start with this middle line to complete the square, where I want to put something in this blank line that's going to make a perfect square right here. A trick for finding what you need to put in this line, and you may have learned this in your secondary math 2 class, is you take that middle term, divide by 2, and then you square it. So if I take this middle term and I divide by 2 and square it, then I get a 4. So this is what we call a perfect square trinomial. If I factored this, you would end up getting that middle term divided by 2, and that's what goes here. So if you take this and you square it, you would end up getting this. So now the point is, I have a 4 here. Well, if I want to end with an 8, what would I need to put here so that both of them together make my 8? Well, that's going to be another 4. So that's what goes in that spot. So this is the completed square version of this. They're the same equation, just different versions. So now I can rewrite this integral as 1 over x plus 2 squared plus 4 dx. And, hey, look at that. This integral is going to be an arctan, because I have something squared and something squared. This is my x plus 2 squared. This is my 2 squared. So that x plus 2 is going to be my u. That 2 is going to be my a. I can do my u substitution, but you'll notice when you take the derivative, du is just going to equal 1 dx. So that right there, that's already du. So if I rewrite my integral one more time, I'm going to get u squared and 2 squared. So now it's in my arctan form. So this is going to be arctan of u over 2. Well, my u is x plus 2 over 2. And remember, arctan always has that 1 in front. That is also 1 over a, or 1 over 2. And that right there should be your final answer. Okay, let's do our last example, example number 11. I want to do this one with you guys because this one is also pretty weird. So if I take this one, there's not a good way to do this. If you started by trying u substitution, you would find that du is going to be e to the x dx. But I can't add an e to the x and 1 over e to the x, because remember, you can't add letters, only numbers. So u substitution is not going to work. I can't just straight up integrate it because of this plus 1. If that plus 1 was there, I could just do this and go from there. Can't do that though because of that plus 1. So I'm going to do something very tricky. Up in the numerator, I'm going to add e to the x and subtract e to the x. Then I'm going to separate this into 2 integrals, both over e to the x plus 1. The first integral is going to include my first 2 terms. The last integral is going to be this one, and I'll subtract them because there's that negative in front. Now if you look at this, 1 plus e to the x over e to the x plus 1, that's just 1. And now if I look at this one, now I can do a u substitution with this, and it's going to work. I get e to the x plus 1, so du is e to the x dx. So all of that is my du. So I end up with the integral of 1 over u du. Let's keep going. Integral of 1 is x. 1 over u is going to be ln of absolute value of u. And my u is e to the x plus 1. And then I have my plus c. And that's our answer. That is it for our integration rules and techniques. We are done with learning new rules, and from here it's just practicing these rules over and over and over to get them all memorized.